NASA's James Webb Space Telescope launched at 7:20 a.m. EST Saturday on an Ariane 5 rocket from Europe's spaceport in French Guiana, South America. A joint effort with ESA, European Space Agency, and the Canadian Space Agency, the Webb Observatory is NASA's revolutionary flagship mission to seek the light from the first galaxies in the early universe and to explore our own solar system, as well as planets orbiting other stars, called exoplanets. The world's largest and most complex space observatory will now begin 6 months of commissioning in space. At the end of commissioning, Webb will deliver its first images. Webb carries 4 state-of-the-art science instruments with highly sensitive infrared detectors of unprecedented resolution. Webb will study infrared light from celestial objects with much greater clarity than ever before. The premier mission is the scientific successor to NASA's iconic Hubble and Successor space telescopes, built to complement and further the scientific discoveries of these and other missions. The telescope's revolutionary technology will explore every phase of cosmic history, from within our solar system to the most distant observable galaxies in the early universe, to everything in between. Webb will reveal new and unexpected discoveries and help humanity understand the origins of the universe and our place in it. Ground teams began receiving telemetry data from Webb about 5 minutes after launch. The Ariane 5 rocket performed as expected, separating from the observatory 27 minutes into the flight. The observatory was released at an altitude of approximately 75 miles, or 120 kilometers. Approximately 30 minutes after launch, Webb unfolded its solar array, and mission managers confirmed that the solar array was providing power to the observatory. After solar array development, mission operators will establish a communications link with the observatory via the Malindi ground station in Kenya, and ground control at the Space Telescope Science Institute in Baltimore will send the first commands to the spacecraft. Engineers and ground controllers will conduct the first of 3 mid-course correction burns about 12 hours and 30 minutes after launch, firing Webb's thrusters to maneuver the spacecraft on an optimal trajectory towards its destination in orbit about 1 million miles from Earth. At 7:50 p.m. EST, Webb's first mid-course correction burn began. It lasted 65 minutes and is now complete. This burn is one of 2 milestones that are time critical. The first was the solar array deployment, which happened shortly after launch. This burn adjusts Webb's trajectory towards the second Lagrange point, commonly known as L2. After launch, Webb needs to make its own mid-course thrust correction maneuvers to get to its orbit. This is by design. Webb received an intentional slight underburn from the Ariane 5 that launched it into space, because it is not possible to correct for overthrust. If Webb gets too much thrust, it can't turn around to move back towards Earth, because that would directly expose its telescope optics and structure to the sun, overheating them and aborting the science mission before it can even begin.